Hello everyone, and welcome to Virtual Chemistry for Chapter 8. In this chapter, you will learn how to determine a compound's formula. Before you can do that, however, we need to think about counting atoms. How do we determine the number of each type of atom in a substance so that we can write its formula? Of course, atoms are too small to count individually. As we will see in this chapter, we typically count atoms by weighing them. So let us first consider the general principle of counting by weighing. To help you understand this concept, we are embedding a few videos from Tyler DeWitt taken from YouTube. Before watching the videos, we need to explain how to describe the mass of very tiny things called atoms. Because atoms are so small, the units we use in lab, like grams and milligrams, are too large to use with a single atom. Scientists developed a unit called the atomic mass unit, or AMU. 1 AMU is equal to 1.66 times 10 to the negative 24th grams. I think you'd all agree that it's much easier to use the atomic mass unit than grams to describe the mass of a single atom. One more thing before watching the video. On the periodic table below the element symbol, you will find a number. This number is the average atomic mass, or sometimes just called the atomic mass, of any element. The numbers usually have decimals. They are very rarely whole numbers. We've talked about mass number, which is just the sum of the protons and neutrons in an atom. This number is not that. In the video, you will see how that number is generated. Because we have learned about isotopes, you already know that not all atoms of an element are identical in mass. If we can use the average mass of an element, we can figure out how many atoms we have in a given mass of a sample. All you need to know is the mass of the sample and the average mass of each atom. You don't need the exact mass of any atom. One example is carbon. The average atomic mass of carbon is 12.01 AMUs. We know there are multiple isotopes of carbon. Some have 6 neutrons, some have 7, and others have 8. These isotopes all have different masses. We can figure out how many atoms of carbon are in a sample of carbon by using this average atomic mass. Now watch the video where you will see a bit more about how this average is calculated. Since we never work with just one atom, the atomic mass unit, or AMU, doesn't have much use for us. Scientists have developed a number called Avogadro's number. That allows us to count large numbers of atoms by weighing them in grams. Avogadro's number is called the mole. A mole is like a dozen, only much larger. Our book uses the number 6.022 times 10 to the 23rd particles per mole. That means a mole of anything has that number of particles. The great thing about the mole is that we can change the way we think about the atomic mass. We can now call it the molar mass. The atomic mass on the periodic table is the mass of a mole of that element in grams. For example, 1 mole of carbon atoms weighs exactly 12.01 grams. That we can measure. Take some time and watch Tyler explain the mole. Our book uses a slightly different number, 6.022 times 10 to the 23rd. Tyler will use 6.02 times 10 to the 23rd, and we will accept either on the test. After this video, move on to work using moles and atomic mass as conversions. So now that I've told you what molar mass is, we can examine the molar mass of several different elements. Each of these samples has a different mass, but contains the same number of particles, 1 mole. In looking at this slide, we see the comparison of 1 mole samples of various elements. And notice that they use MOL as an abbreviation for mole, MOLE. Either one is fine. In the left-hand column, we have the name of the element, and then in the center, we have the number of atoms present, which is exactly 1 mole. The right-hand column has the mass of that sample, which is the atomic mass from the periodic table. Notice that for all of the elements, no matter how heavy or light they are, The number of atoms present is 1 mole, or 6.022 times 10 to the 23rd. The mass depends on what the average mass is for that atom. So 1 mole of aluminum only has a mass of 26.98 grams. That's just about an ounce. A mole of gold, while the same number of particles as a mole of aluminum, has a much larger mass because gold atoms are heavier than aluminum atoms. This is just a look at various samples. It's not meant to be something you have to memorize. A mole of hydrogen atoms weighs just a little more than 1 gram. That is a lot of particles to be in such a small mass. We will now look at a few of the experimental examples or concept checks for this chapter. So the first concept check says, determine the number of copper atoms in a 63.55 gram sample of copper. 63.55 grams is the atomic mass of copper, which means that there is exactly 1 mole of copper atoms in a sample of 63.55 grams, since that is equal to the atomic mass. So a mole of copper, or a 63.55 grams of copper, contains exactly 1 mole, which is 6.022 times 10 to the 23rd copper atoms. In this slide, we have a sample of 26.98 grams of aluminum, and we want to know how many grams of gold has the same number of atoms as 26.98 grams of aluminum. If you look on your periodic table, you will see that 26.98 is the atomic mass of aluminum. 26.98 grams is the molar mass of aluminum. So we need to find what the mass of gold is on the periodic table, and that will give us the right answer. And if you look on your periodic table, the mass of gold, that is the molar mass of gold, is 197.0 grams. So that is the correct answer. Hopefully now you have the concept of moles and molar mass down. Since molar mass relates to units, mass and moles, we can use it to convert between units just like we did using conversion factors like 100 centimeters equals 1 meter or 100 milligrams equals 1 gram. This slide is here to remind you of the principles to follow. What do I know, where am I going, and how can I get there? Always check at the end to make sure your answer makes sense. The first thing we need to do before we can do conversions is learn how to find the molar mass of a compound. Note that MOL, again, is the abbreviation for mole. For individual atoms, the molar mass is simply the mass of a mole of an atom, which is the atomic mass on the periodic table. The unit is grams per mole. So on this slide, the molar mass of N, or nitrogen atoms, is 14.01 grams per mole. However, for a compound or any molecule, you need to add up the masses for each element in the compound. If the element has a subscript other than 1, you need to multiply the mass of the element by that subscript. So for water, which has the formula H2O, the molar mass is 2 times the mass of hydrogen, which is 2 times 1.01, plus 1 times the mass of oxygen, which is 1 times 16. Added together, that makes a molar mass of 18.02 grams per mole. Compounds such as barium nitrate, Ba parentheses NO3 close parentheses number 2, are more complex. You need to multiply the subscript on the polyatomic ion, in this case the number 2, by the subscripts in the formula of the ion to get the number of atoms. So this compound contains 1 barium atom, which has a mass of 137.33 grams per mole. It contains 2 nitrogen atoms, which have a mass each of 14.01, and it contains 6 oxygen atoms, which is 6 times 16. When you do the math and sum them all together, you get 261.35 grams per mole. Be careful with these types of compounds and make sure that you multiply the subscripts together and not add them. In the last slide for this particular presentation, watch Tyler demonstrate a whole bunch of molar mass calculations. After this, you should take some time to work the problems on the worksheets. We have added a worksheet to Canvas that is just 12 molar mass calculations. You can do those, you can find more in the book, and if you want more, send me an email and I'll be happy to create some more. That's the end of this first presentation.